Alright, what I'd like to do is show you one last confidence interval, and that is how to calculate the confidence interval for the population proportion P using Minitab Express and the TI graphing calculator. So this is the Biff Bullshooter question that is in the PDF on Blackboard for calculating a population confidence interval using the population proportion. So again, I've run through how to crunch the confidence interval by first getting the error of the confidence interval and then calculating the confidence interval using the defining formulas. Using Minitab Express, this can be done in seconds. So this procedure is rather lengthy to do it by hand using formulas and some type of hand calculator. But the inference menu here, very fast to use. It's the one proportion menu, so you select that. Sample data in a column. Do we have our data in a column? The answer is no. They told us, they summarized it, said they asked 600 people, and 317 said, yeah, we're voting for Biff. So they want us to use that as a statistic to project, what the percentage is going to be for all of Nassau County. We don't have that. We have the summarized data. So it says number of events, number of trials. All right, well, number of events is 317 events. And the number of trials, that's the total number of people that were asked. In this case, it's 600. We are not performing a hypothesis test yet. Under the options column, there's a couple of methods. We are going to use the normal approximation. So make sure you check that. And this method, if you're wondering what the exact method is, that uses the t-distribution. So we are going to leave 95%. This is actually a 95% confidence interval, as you can see. Remember, leave this on not equals to, the alternative hypothesis. And again, select normal approximation. So once these menus are all set up, we're all ready to go here, say OK. And here you have the confidence interval, 0.4883. 0.4884. As you can see, this 9 right here tells the 3 to bump up to a 4, so it gets me the same answer here. And 0.56827, 0.5682. So obviously you see the values here and the values here are very, very close. It also shows the spread here, obviously, in terms of a kind of like a box plot. But for now, we're not going to really worry about this picture. It even lets you know that you selected the normal approximation. So the normal approximation is discussed in the packet here. After I define the formulas, it lets you know about when you could use z-scores. It's an assumption. When n times p and n times q are both greater than 10, that allows us to use z-scores instead of t-scores. So for our examples, we're always going to follow this assumption right here. But in the real world, that may not always be true. So in some cases, you may be using the t-distribution. But for examples in our class, we'll always use the normal, what we call the normal approximation. Now, the same procedure can be done in the calculator. It's just as easy. You access the statistics menu by hitting stat. Bouncing over to the test menu, so move over there. And then you gotta follow down for a while and locate the confidence interval for proportions. I believe it's letter A. This calculator is really slow. Here we go, letter A. 1 prop z interval. Prop meaning proportion, int meaning confidence interval, and notice it says z. So, because it's with z-scores. That's the normal approximation. Alright, so you select that option there. And it's real basic what it's asking you. What's x and what's n? And that's handed to you in this question. So in this question here, x was 317, and then the n was 600. So in other words, 317 people said, yeah, we're going to vote for Biff. Out of the 600 people. The default for the confidence level is 95%, so I don't need to change that. And you just go on top of calculate, And as you can see, the results here are the same as the results here. It also calculates the sample proportion, p hat. Now I calculated p hat over here when we described how to crunch the p hat. Remember, that's x divided by n. That's 52.83% approximately. That's the percent of people in your sample that say, yeah, I'm voting for Biff. That's the value used to estimate the value of p. So it's this value right here, 0.5283, give and take some error, which is that 0.0399 number. So that's where this calculation comes from. Now remember, when you use the software to get the confidence interval, it does not tell you the value of the error in the confidence interval. Now don't mix up the error for the confidence interval with the standard error. The standard error typically is sigma divided by radical n. But once you take the sigma over radical n and multiply it by that critical z-score, you get the overall error of the confidence interval. So remember, when you use the software, it doesn't tell you that error. So if you want the error, you take the lower and upper bound of the confidence intervals, you subtract them to find how far apart they are. The distance that they're apart is actually double the error. So once you subtract these two numbers and get that result, cut that in half by dividing by 2, and that'll get you this 0.0399, the error. So you don't even have to use this error formula to crunch the error. You could use the software, either the Minitab or the calculator, crunch the confidence interval on there, subtract the two numbers, divide by 2, that'll always get you that error. Alright, if you have any questions,